All right, these notes are going to be on something called synthetic division. And synthetic division is used as a replacement for polynomial long division when you are dividing by a linear factor with a coefficient of 1. And this should say leading coefficient of 1. So with a leading coefficient of 1. So here's what I mean. If we are looking at a problem, here's our example, where we have x to the third plus 2x squared minus x minus 2, and we're dividing this by x minus 1, we could use synthetic division to do this problem instead of polynomial long division. And that's because if you look at what you're dividing by, this is linear. It's got an x, not an x squared, not an x to the third. And the x itself has a leading coefficient of 1. So that problem would be totally fine to use synthetic division with. Now, if we look at some of these other problems on this page, so this problem where we're dividing by x plus 3, synthetic division would work there. X minus 2, synthetic division would work. X minus 1, synthetic division would work. But if you look at these other problems, they're dividing by a quadratic, something that starts off with an x squared. So synthetic division would not work here, it would not work here, it would not work there, it would not work here. All right, and then yesterday in class we also did some problems where you might divide by like 3x minus 1, and synthetic division, you can technically do it, but it's students get it confused a lot, so I'm not going to show you how. So we only can do it in the most simple of cases, which is why we did not start off the unit using synthetic division, because it is much easier than polynomial long division, but it does not always work. And so we want to make sure that you guys understand that this is kind of a shortcut that works for those simple problems, but ultimately we are going to work on the skill of polynomial long division because that skill is important for future math classes. So here is how synthetic division works. First, you have to figure out what your root is. And your root is the opposite sign of whatever was in your linear factor. So I'm going to say the root is x equals 1. And then we're going to draw a little box. And we're going to put that root inside the little box. After that, we take the coefficients for each of these, and it is very important, like with polynomial long division, that you have every single exponent being represented. So we've got exponent of 3, exponent of 2, exponent of 1, and then no exponent here. And so next to this, I'm going to write the coefficients. 1, 2, negative 1, negative 2. All right? So our first step was to find the root and put it in a box. Our second step was to bring down the coefficients. All right, our next step, we draw this line underneath and we put a box right here. And this box right here is for the remainder. So this is the remainder box. All right, so here's what we do. We drop down the first number. And then after this is where the process gets repetitive. So I'm going to take the 1 and multiply it by the number in this box. 1 times 1 is 1, and I write the number right here. And then I add those numbers together. That's a 3. 3 multiplied by 1 is 3. And then I add those numbers together, and that gives me 2. 2 times 1 is 2. And I add those numbers together, and I get a remainder of 0. So what we are going to do is we are going to multiply this number. I'm going to put step 4 over here. Multiply the bottom numbers by the number in the box. And then write it underneath the next coefficient. Add the numbers together. Repeat. So our last step is to write the equation, or write the remaining expression, is how we should phrase it. The exponents drop by 1. So our original problem started with an x to the third. So our answer is going to have an x squared in it. And this is the coefficient for the first term. So we're going to say our answer is 1x squared plus 3x plus 2. And we do not have any remainder, so there should be no fraction at the end. And so this is our final answer. Okay, so it seemed complicated because we just wrote out a lot of steps, but now we're going to do a couple problems, and you will see that it's not too bad. All right, so here's the next problem that we're going to do. We are going to try 5x to the third plus x squared minus 7 divided by x plus 1. So first I'm going to look for my root. My root is -1, and -1 goes in that box. Next, I'm going to write down what my coefficients were, and I have to make sure that I don't miss any exponents. So this was x to the third, x to the second. I'm going to need an x that's by itself, so that would be 0x, and then the -7 on the end. So my coefficients are 5, 1, 0, -7. I go ahead and I draw my line underneath. I leave a space open down here for my remainder. The first number always is brought down, so that's step 3, always drop down the first number. So we're going to drop down the first number, and that first number is 5. And then here is where I do step 4. I multiply the bottom numbers by the number in the box, and then write it underneath the next coefficient. So the bottom number multiplied by the number in the box gives me -5. And I wrote it underneath the next coefficient, and now I add these numbers together. So 1 and -5 makes -4. Now I take this number and I multiply it by the number in the box. -4 times -1 is +4. I add those numbers together, and that gives me +4. And I write it down here. Then I multiply the numbers together. 4 times -1 is -4. And then I add those numbers together, and I get -11. So last, I'm going to write the remaining expression, and the exponents should decrease by 1. They should drop by 1. So if this is an x to the third, then I'm going to write 5x squared minus 4x plus 4. And then this must have been my fraction, so I've got minus 11 over x plus 1, because x plus 1 is what we would have been dividing by if we were doing polynomial long division. Alright, next we're going to do x to the 4th plus 3x to the 2nd minus 5x minus 8 divided by x minus 2. So again, when I set this problem up for synthetic division, I'm going to have to make sure that I have all my exponents represented. So I have an x to the 4th, but I do not have an x to the 3rd. So in here I'm going to need a 0x to the 3rd, and then x to the 2nd, and then a plain x, and then no x. So my root here is positive 2. So 2 goes in the box. And then I have 1, 0, 3, negative 5, negative 8. I drop down my first number. It's a 1. 1 times 2 is 2. 0 plus 2 is 2. 2 times 2 is 4. 3 plus 4 is 7. 7 times 2 is 14. 14 plus negative 5 is 9. 9 times 2 is 18. Negative 8 and 18 makes 10. So now when we write down our answer, the leading coefficient, or the leading exponent here was a 4, so that means we're going to drop it by 1. So it gives us x to the 3rd plus 2x to the 2nd plus 7x plus 9. There's our remainder, so 10 over x minus 2.